Welcome to the future of understanding. This is NeuroMind Insights, where we unlock the power of your mind.
Every single morning, billions of us participate in a quiet global ritual. We consume a chemical compound precisely to alter the physical state of our minds. We reach for these substances to fill a specific void. We swallow, sip, and inhale, expecting these chemicals to provide things we currently lack, whether that's a surge of focus, a sense of peace, or a social bridge to others. Biologically, drugs rearrange existing neural resources. They mimic natural signals or temporarily obscure others, creating the sensation of a change that hasn't actually occurred within the brain's baseline chemistry. If a drug isn't actually adding anything new to the system, how does it manage to manipulate our perception so effectively? And what is the biological cost of maintaining that manipulation? The pursuit of energy often begins with stimulants. We rely on compounds extracted from plants, like coffee beans and tobacco leaves, to push our bodies past the point where they would normally demand rest. Caffeine molecules function by physically lodging into neural receptors, which prevents the brain from receiving adenosine, the chemical that signals tiredness. By blocking this signal, the brain remains unaware of its own exhaustion, allowing neurons to keep firing despite the lack of rest. While caffeine obscures fatigue, more powerful stimulants like cocaine and methamphetamine hijack the neural network by flooding it with internal resources. This chart tracks dopamine. A heavy stimulant forces the brain to burn its natural fuel supply in a single massive surge. Because it exhausted its reserves, dopamine plummets far below baseline after the drug clears, leaving the system depleted and craving another hit. Stimulants do not generate energy, they simply shift it. They borrow motivation from the future, leaving the brain in debt during the inevitable crash. Escaping stress or physical pain requires a different chemical approach. Depressants like alcohol and benzos are frequently used to quiet the mind or numb the body during social gatherings and moments of high tension. These substances slow the nervous system by enhancing GABA, a chemical that signals the brain to quiet its electrical activity. This forced deceleration mutes the intensity of sensory input and internal thought. In this state, physical tension relaxes and social barriers seem to soften. The brain processes the world with a sense of distance, making stress feel manageable or even non-existent. However, the brain views this artificial slowing as a threat to its equilibrium. To compensate, it ramps up its own internal activity, pushing back against the drug's effects to keep the system running. When the drug wears off, the brain's heightened activity continues without the chemical break. This biological whiplash causes the jittery anxiety of a hangover or the physical overactivity and panic associated with opioid withdrawal. The calm provided by these substances is temporary. As the body restores its balance, the peace vanishes, replaced by the very anxiety it was intended to soothe. A third pursuit involves the search for empathy and mental expansion through substances like MDMA, LSD, and psilocybin. These chemicals operate by flooding the system with serotonin, or altering the perception networks that normally maintain a clear sense of individual self. During the peak of the trip, senses can become intensely heightened. This often leads to a profound feeling of connection with others and the environment, as the brain's usual boundaries of identity are chemically lowered. This extreme activity drains the brain's serotonin supply at an accelerated rate. Exhausting these stores can damage the pathways responsible for regulating happiness and empathy. The result is a period of emotional emptiness or sadness that persists once the drug has left the system, as the brain waits to slowly rebuild its chemical reserves. The expansion felt during the trip depends on this temporary chemical surge. Once the supply is depleted, the brain often struggles to find that same sense of empathy through its own natural mechanisms. This scale represents homeostasis, the brain's mechanism to maintain equilibrium. When pushed to a chemical extreme, it compensates by swinging into the opposite state. Every artificial peak mandates a corresponding trough, as the body finds its center. Chemically altering your state of mind functions as a high-interest loan against your body's natural stores of energy and emotion. Over time, the constant demand for chemical shortcuts leads the brain to reduce its natural production. Eventually, the mind may struggle to experience joy, calm, or alertness without the external substance. Sustainable energy and connection require natural generation. Relying on chemical shortcuts inevitably triggers a biological correction, and that correction always carries a cost.
Thank you for watching. If you enjoyed this video, please like, comment, share, and subscribe to NeuroMind Insights for more.